everyone, thanks to come to my talk. Today we are going to discuss about the continuous integration of the FreeBSD project, aka ci.freebsd.org. That's it. So first of all, something about me. My name in Mandarin will be Xu Liwen. So I'm from Taiwan, as known as Formosa, and I was the system administrator, was the instructor. Now I'm a programmer, and I also like to travel. And in the summer, I like to do scuba diving. In the winter, I like to go snowboard. And for the spring and fall, I ride no bikes. Yeah. So, yeah. First of all, yeah, good people with rigorous engineering process doing BSD. That's what Carol from FreeBSD said in BSDCan 2014. And even if that, we still need a more higher quality of FreeBSD. In that, we hope we can have higher quality releases, and for developing branches, for current we want it always buildable, and for stable branch we hope it is also reliable, and we also want them stable and cannot and the development speed should be faster. Yeah. So there's the word in software development called release early, release often. How to do that? We need to test early and test often. Yeah. And there are many tests, such as unit testing and integration test. Yeah. So test is very important, and the integration test is more important, and we need to do it continuously, yeah, or something will fail. Yeah. So continuous integration, CI, it is a term created by Grady Borch in the 90s, and it is a suggestion or a software engineering practice that tell people merging all their work at least once a day. And the main idea of this is we need to know conflicts and the bugs as early as possible. Yeah. So on Wikipedia, there are some suggestions. Those are not standard, just some suggestions. Yeah. And for FreeBSD, we do have a central resource repository from the beginning. So yeah, we do it right at first. And since we are an open source OS project, so some of them might not just apply to close it out. And so what's left is what we need, and we can divide them a little bit. What we do from the bottom of the screen is we need help from everybody. We need everybody to commit correct code. That should be very hard, and try to make your code build faster. But that also can be done by buying new and faster machines. Anyway, for the upper four items, which can be provided by a good CI systems. What we want is automatic build system, and we should make those build self-testing, and the result of the build and the test result can be easy to get, and everybody can see the results. Yeah. So following, we were talking about those items. Yeah. So first of all, automatically build and some history. Yeah. starts from 2002 to 2014. We have a service called Tinderbox, which is done by S. And the URL is tinderbox.freebsd.org, which is probably started in March 2002 and probably stopped in September 2012. Yeah, I just digging in the mail archive and found the first one message and the last one. Yeah, the code is available in user branch on sbn.freebsd.org, and it is well documented. You can see in developer's handbook and Tinderbox wiki page. Yeah. So this is what it was like. I grabbed this picture from the web archive because currently Tinderbox is gone. Yeah. So 2013, Greg create a group called the Jenkins Admin, which has several members now and some alumni. So we had the first working group in Canada 2014, and there are some small discussions in the following conferences, and we had the second working group in Serbia last year, and yesterday we have third working group. Yeah. So more information can be retrieved on Jenkins web page or Jenkins/wiki page. Yeah. So Jenkins. Jenkins is an open source automation server written in Java by a Japanese guy called Kosuke Kawaguchi. Yeah. The URL is there, and it is the most popular automation server used by the world currently, and we use that for continuous integration or even continuous delivery. The best part of it is it can be extended by various plugins to add new features, new functions of it to it. Yeah. So we create a site called Jenkins.freebsd.org, which is operated and maintained by Jenkins admin, of course. So, which is an independent successor for Tinderbox.freebsd.org. So what we do is periodically build and test the FreeBSD source and documentation tree. So we build several branches and for several architectures, and we also do some non-standard tests such as build with GCC. So what was done there is just using close tool chain. So we are using ND64 to close build the ND64 itself. So and the scripts and the code are available in FreeBSD's GitHub organization. So it is what it looks like. However, currently it is suffering some hardware issue. Anyway, last summer I started a new experiment with the help from the FreeBSD Foundation. I create a ci.freebsd.org, and it is also based on Jenkins. So I just use the experience and the ideas from Jenkins.freebsd.org, and I try to extend it more for trying new ideas and some new features. The best part of it is we introduced the artifact server. So there are two main uses of it. One is to passing artifacts between each stages of a pipeline. Another is before launch we just throw everything except the test results. But for now we keep every build results for public to download and they can do further tests. And we also create some job template or some scripts trying to help other people might not know Jenkins that good to create their own CI jobs more easily. So the configurations and the codes are currently in my fork repository on GitHub, and I will merge back it very soon because I was being asked by people yesterday. Right. So the pipeline of it is basically the same as Jenkins.freebsd.org. However, I added 2 jobs right after build a job, which is I'm trying to build a linked kernel, and I also produce virtual machine images, not only for test only. I'm trying to produce virtual machine image in the same way as we provide the release or a snapshot, so people can always get can test the latest code more easy. So for the first jobs, build jobs, we have job name suffix with build and linked. So for build jobs, the script is under scripts/build/build one and kernel.sh. What it does is, which is generalized script for different versions and architectures, and it simply just execute the make build word and make build kernel, and use the result to produce distribution files. So we have several .txt files, just the same as what you get on downloads.freebsd.org. And we build a linked kernel for check everything is more than generic kernel. Yeah. So step tests. From NetBSD, Mario create Kuya, which is a testing framework for infrastructure software, and the repository is also on GitHub at his personal repository, and it also will documented is a wiki on his GitHub repository, and he also gave talk and the tutorial 3 years ago here. You can find the materials there. And we need a place to run tests, so it's better to do that in a controlled environment. So we use a virtual machine right now, and because we are testing FreeBSD, so we use Beehive. So Beehive is the BSD hypervisor. You can find more information on beehive.org, which is building in FreeBSD since 2.0. And on ci.freebsd.org, we have 2 kinds of job. One is images, and another is suffixed by test VN, which builds the ordinary VN images. Another is ordinary VN image plus some test scripts. So we pre-install the Kuya package and some scripts to automatically run tests, then shut down the virtual machine. And yeah, that's basically what jobs suffixed by test do. And for ND64 and i386, we used Beehive to test. But for other architectures, such as RISC-V, we use QEMU to run boot test inside it. Currently, we only do boot test for RISC-V. We don't run any further tests. But at least we should confirm that RISC-V architecture generates bootable image. Yeah, so putting them together, first of all, we create a new virtual machine image and we install CreatePG and the tester files inside it. We customize the rc.local script in which we run tests and generate test report and then shut down the virtual machine. The script is available also in scripts directory called build test image.sh. And another job which will run tests in virtual machine. So what it does is fetch the VM image and boost it, wait for it to complete, and or if it time out, just kill it. After the virtual machine shut down or be killed, we mount the VM image and extract the test result from it. The script which does everything is under tests and run tests.sh. Yeah. So how do we access those script results? So also in this project, we asked we cooperate with Julio to make Kuya to produce JUnit format output, which is not very readable by human. However, it can be parsed and displayed by Jenkins. So we will have have a very beautiful test report tell you what's success, what's failed. So yeah, for this example, everything passed, which is good. But when something failed, just like this, so we will see the test case name and the error message, what output standard out, what's the standard error displays, so which can help developer to know what's going on. Yeah. And another best part of Jenkins is you can track the test result trend. So we provide a picture to let everybody knows the status of our project. We are doing things better and better, or we are produce lower quality code. So artifacts, as we mentioned many times before, currently we produce 3 kinds of artifacts. First of all is .txt files, which is come from build jobs. So which is basically the same file just like what we have on download.freebsd.org. So you can just grab those txt files, say base.txt or kernel.txt, and install your machines and get and try the latest feature. And another 2 disk images is disk image.xz and disk test image.xz. So you can just tell from his name. This image is created by Jenkins Job, which is ordinary virtual machine disk. So you can just grab it, put it on every hypervisor you like, such as VMware or VirtualBox and so on. Yeah, and then try it. And for disk test image, which is generated by test VM jobs. So if you grab this kind of VM image and put it in QEMU or VirtualBox, you can reproduce the test steps. And if you found anything wrong in the test report, you can try to reproduce that error. So artifact.ci.freebt.org, which runs 2 daemons. One is FTP daemon, and another is HTTP daemon. So for FTP daemon, we use FTP over TLS to serve files uploading from each build jobs. So we use Jenkins publish over FTP plugin to upload those artifacts after the building job is done. And when doing this, we add the FTP over TL as supported into that plugin and merge to the upstream. And we just run NGX for downloading, for serving those artifacts to the public. We keep a directory layout. We try to keep the directory layout the same as official download site. So there is a directory called snapshots. Under it, there are several subdirectories, branches, SVN revision, target, and target arc. So, say for head and ND60 arc and revision 30326, just available in this directory. Yeah. And so that's how CIWB.org does, and you can just open CIWB.org and see everything is running. So while doing setting up this work, we want to, everybody can download the Jenkins and run it locally. However, because we are trying to build open services, so we are trying to make things as open as we can. However, we also need to keep it as secure as we can. So so we were talking about how to do this. So we use Jenkins Job Builder from OpenStack project. Before that, Jenkins Job can only be added on its own web interface, which is very we can out the job very quickly. However, it's not very scalable, and there are many drawbacks. So Jenkins Job Builder can provides a YAML to Jenkins configuration mapping, and by using that, we can create or update or even delete Jenkins jobs through its web services. And by using that, we can make Jenkins configuration trackable and reproducible. So, such as we can just save those configurations into a version control system. So, for CIWB.org, every its configurations are currently saved in my personal GitHub repository there. And we also found that not everybody knows how Jenkins works, and we also don't think that everybody has to know how to configure Jenkins, because some people just don't want, and we don't want to waste everybody's time to do that. And then we found that most of the build jobs just have different build scripts. So we created a set of job template which can do environment setup and execution specified build script for that job, and then just clean the environment. That's it. So for environment setup, there are 3 steps. First is just check out the latest scripts for following operations, and by using that, you can specify which version of FreeBSD you want to use, and install required packages for your test. So by using job template and Jenkins Job Builder, a job definition is simplified as this. So this is a simple to execute jobs. Your testing job in GL, which we will cover later. So first of all, the main idea of this is we are trying to make configuration as simple as possible. Yeah. So building GL script sets are in the scripts GL directory. The main purpose of it is trying to provide a clean environment setup for each job configurations, for each job when running each job. So 3 steps, as we mentioned before, is setup, execute, and clean. And inside that GL, we install Sudo by default. So in your test, you can use Sudo to customize your environment to what you need for your test. So typical job configuration contains 3 parts. First of all is build.sh, which is the main script you must provide to tell us how to run your tests. And another two is gl.conf and the pkg list. gl.conf contains the GL environment configuration, so you need to specify what's the environment you want. So specify version, architecture, or such, and the others. pkg list is just a package list you want to install before your job is queued. So for having this, adding a new job becomes very simple. Submitters just bring their own build scripts and configurations to us. So just load 3 files: gl.conf, pkg list, and build.sh. Or even that, you can also add some new files such as source.conf or make.conf and use that in your build.sh. So Jenkins admin just merges your scripts and the configurations to the FreeBSD repository with your job's name, and we create a new entry in Jenkins Job Builder, the YAML file you just saw, push it to the Jenkins server. Stop. Jenkins will execute it around clock. So this is an example for FreeBSD had Untitled view. So JOS.conf just shows we use AMD64 for building as the building environment. We don't need 32-bit support, and we won't release 11.0 release. So for Untitled, we need LD from bin utilities. So just install that, and build.sh just specify we are building Untitled for ARC64 architecture, and execute build board and kernel script. That's it. And once more is for this building GL script set is we provide a mode called quarantine mode, so which is used to build source or documentation tree with the patch from external, because even if you are running inside GL, you can do whatever with shell script. So if we specify the quarantine mode in gl.conf, we will remove network connection after grab your page, merge it, install the packages you need, and then we just remove the network connection and have strict timeout setting to make sure you are not the pages are not doing anything evil. Yeah. So about other smaller integrations, first of all is the notifications. Yeah, because we have created a test pipeline, and we want that developer know when their code doesn't build or test failed. So when to notify, we notify them when build failed or unstable. Unstable means which can compile successfully, but the test just failed. Or and we also notify them if their fix really work. That means build back to stable. So, and how to notify? Currently, we notify developers in two ways. One is email, another is we have a IRC channel called FreeBSDCI or FreeBSDCI commit or FreeBSD commit. So we just post the message that test fail or build fails. Right? So for email notification, we used to send lots of email to FreeBSD email list. It's some kind of double-edged sword, because if we spend the mailing list too much, so nobody will read them, and if nobody reads these messages, what the whole thing we are provided is totally no use. So we use Jenkins' email extension plugin to try to provide better notification content and trying to eliminate the false positives as much as we can. So reduce first alert. We are trying to be more careful before sending notifications, because in some cases, build failed are not caused by a broken code. It's probably just because of environment such as build self just outage or network outage. So we have a movie script layer to before sending out a mail, we filled out we scan the error log and try to figure out the root cause of the error. If it is internal error, we just notify Jenkins admin. Yeah. So notification contents. We also use email extension to customize the mail body. Yeah. So for failed or unstable build jobs, we have a template like this. We tell which job fails and which build number and the status of it, and we provide some the detailed build information and some URLs, and we include change summaries. So because we build it, we trigger a new build every 5 times if there is a change in log range of the main repository. So one build may contains several changes from different developers. So we just list all the changes in that build to that everybody knows who might be the codes easier. And we just send the last maybe 1 or 200 of the build log to try to make them figure out what's going on quickly. Yeah. So the build fail mail is like this. Sorry. The build fail mail is just like this. We have the URL contains detailed information and the who changes what and the end of the build log. So you can see for this field, just probably they just want to add some file. Okay. And for tested jobs, we also provide the information through several URLs, and we also list the fail cases at the bottom of the message. So the example will like this. So in this fail, in this mail, there are 2 tests failed. So we list the name of the test and the error messages. Another thing we have done on ci.freebsd.org is we have integration with our code review system, Fabricator. For Fabricator has a Jenkins plugin which is created by Uber. So it's available on Uber's GitHub, and I think it is moved to official Jenkins repository now. But it has a very good README file, so just follow it. You can set up Jenkins and Fabricator integration very easy. And currently it supports only Git. However, for FreeBSD we are using Subversion as our main repository. So we also patched this plugin, and currently it's only available in my personal fork, but I will arrange it and try to merge back later. Yeah. So the build triggered by a new page created in Fabricator will have page number attached to the build information, so you can see these blue numbers means the page numbers. So yeah, and here you can see some page success the build or some page fails to the build. And in build page there is page information attached. So on Fabricator you can see the build the build status of your page. So green, of course, green means your page is built, and red means your page just failed. So it can help the page submitters and the reviewer to know the exactly status of this page. Yeah. Also, we have a Clang scan build job to provide scan builder to run this statistical analyzer to help people to find possible issues in our source tree. And it is also just use we use Jenkins' scan build plugin to display the result, and we also also we import make .mk file from NetBSD, so we can produce this Clang scan build easily by just execute this script. So, and of course we can have a check of the error found by Clang scan build. Yeah. So the bug report will, the scan build bug report will like this. So yeah, we have the file, what's going on. Let's look a little deeper. Yeah. This is one of the issues found by Clang scan build, which means you can see the data flow and the control flow of that bug. So it can help people to provide a higher quality of code. Yeah, and not only provide check for source tree, we also provide linked check for the documentation. Warren Brock from the documentation team writes a program called Eager to provide checks of XML documentation files and the main page files. And currently, it's only before this project, it only generates console output. And I worked with him to try to have it to generate XML output, check style output. Check style is a program for Java to check the Java code is followed by standard. And for Jenkins, it also has a check style plugin to display those style violation results. So we use eager output check style XML information and feed this XML result to Jenkins. So by using that, we will have the check style result to display how the documentation quality. Yeah. Also, we will show the test result trend like this. And we are not because we also for source tree we collect compiler warnings by Jenkins Jenkins warning plugin, and so yeah, we also have compiler warnings collected, and of course we have a trend like this. So and finally we provide a build status page. So the page is available through those URLs. So for on64 wiki page, there are some pages on that which shows currently our tree is buildable or not. Right. So those are the main integrations we are using on ci.freebsd.org. And for other Jenkins plugins we used is one is SCN sync configuration. So even if we use Jenkins Job Builder to try to open and keep the configurations in the repository, we also for a full Jenkins setup also contains some configurations we cannot open to public. So by using that plugin, we can track those configuration changes in a version control system. Yeah. And also safe restart. If we change anything, Jenkins sometimes needs to reboot. However, if we reboot, just restart Jenkins, the current build jobs will just fail. So by using that plugin, we can defer the restart command when every running job ends. And it will also start new jobs creation. And finally, we just replacing the default blue balls with green balls because yeah, everybody likes green to state everything is fine. Yeah. So finally, summary of this talk, we hope that continuous integration does really help the development of FreeBSD project. Yeah, in these 2 years, many developers got the build fail mail and trying to fix their code instead of waiting users complain on the mailing list. So we hope those experiments and the code can also help downstream projects or the companies use FreeBSD. So future work, first of all, I hope you can help to work on testing FreeBSD. And there are some inputs from other developers. First of all is we want to use this to check our FreeBSD is reproducible, not only for source tree, but also for the port. And we want to test more, even for some tests not enabled by default, such as features. And we try to build some selected project branches for make people test these branches easy, such as importing new LLVM or some new features such as send file. Yeah. Right, and finally, we also want to do CI for ports, but currently we have tried several times, but currently we still don't have the best way to do it, so we are still working on that. And after that, we probably try to integration some physical bugs to do performance tests. We are currently planning. Yeah. So finally, we want to work with other projects to share the test experience. So finally, thanks everybody to listening, and I want to thank my colleagues on Jenkins admin group, and thanks for FreeBSD Foundation to provide us machines to doing these testers, and thanks for Kai's admin to take care of the physical bugs for us, and Fabricator admin to help the integration. And of course, thanks people on testing, current and stable mailing list to tolerate our spans. Yeah. So, any questions? Yes.
Your team have a plan about all architectures supporting your continuous. Like I see a continuous page. ARM64 is now working, but ARM architecture one George. Jenkins continuous Jenkins node list. I looked at the web. So MD64 I386 AR64, but ARM this. So future plan is all architectures.
Yeah. Because currently we don't have enough computing power, but we of course will have more from foundations. And for the roadmap we discussed yesterday, we are trying to support all tier 1 and tier 2 architectures. Yes. Thanks. So, any other questions? Right, thanks to everybody. Time for banquet.